Comparison of the EMFs of two given cells using potentiometer. The potentiometer wire AB is connected in series with a battery BT, key K, rheostat RH as shown in the figure. This forms the primary circuit. The NA of the potentiometer is connected to the terminal C or a DP-DT switch, that is 6-way key double pole double throw. The terminal D is connected to the jockey J through a galvanometer G and high resistance HR. The cell of EMF E1 is connected between the terminals C1 and the cell of EMF E2 is connected between C2 and D2 of the DP-DT switch. Let I be the current flowing through the primary circuit and R be the resistance of the potentiometer wire per meter length. The DP-DT switch is pressed towards C1, D1 so that cell E1 is included in the secondary circuit. The jockey is moved on the wire and adjusted for zero deflection in the galvanometer. The balancing length is L1. The potential difference across the balancing length L1 is equal to IRL1. Then, by the principle of potentiometer, E1 is equal to IRL1. The DP-DT switch is pressed towards E2. The balance difference across the balancing length is L2 is equal to IRL2. Then, E2 is equal to IRL2. Dividing 1 and 2 we get E1 by E2 is equal to L1 by L2. If EMF of one cell is known, the EMF of the other cell can be calculated using the relation E2 is equal to E1 into L2 by L1.
Kirchhoff's laws. Effective resistance of the simple circuits labeled A and B can be reduced to series and parallel combinations by using Ohm's law. But Ohm's law cannot be used to solve complicated bridge circuits having more than one source of EMF. To solve such bridge circuits, German physicist Gustav Robert Kirchhoff put forth two laws, namely Kirchhoff's first law or junction rule, Kirchhoff's second law or loop rule. Bridge circuits terminology. Junction. A junction in a circuit is a point where three or more conductors meet. Junctions are also called nodes or branch points. Loop. A loop is any closed conducting path. Kirchhoff's first law. It states that the algebraic sum of the currents flowing into any junction is zero. That is, sigma delta I is equal to 0. Consider a circuit having 5 current elements meeting at a point O with currents I1, I2, I3, I4 and I5. To take their algebraic sum, we assume the sign convention. The current flowing towards the junction is considered as positive. The current flowing away from the junction is considered as negative. Applying the sign convention, I1, I3 and I5 are positive and I2 and I4 are negative. That is, I1 minus I2 plus I3 minus I4 plus I5 is equal to 0. Or I1 plus I3 plus I5 is equal to I2 plus I4. The total current towards the junction equals total current away from the junction. This law is in accordance with the law of conservation of charges. Kirchhoff's second law. It states that the algebraic sum of the potential differences in any loop must be equal to zero. That is, the sum of the EMF of the sources of energy in the circuit and the potential drop across the resistive elements is equal to zero. Let us see how the loop rule is used to solve the given bridge circuit. First, draw a circuit diagram to represent the circuit. Mark the direction of flow of current through each branch of the circuit. Then apply the sign convention. According to the sign convention, the EMF of the source is taken as negative if we move from the positive terminal to the negative terminal, and the EMF is considered to be positive if we move from the negative terminal to the positive terminal. The potential drop across any resistor is taken as positive if we move in the direction opposite to the direction of flow of current and vice versa. Consider the circuit shown here. In a closed loop, ABEFA minus I1 plus I2 into R3 plus E2 minus I1 R2 is equal to 0. In the loop CBEDC, minus of I1 plus I2 R3 plus E1 minus I2 R1 is equal to 0. Comparison of the Kirchhoff's rules.
Observe the construction of the potentiometer. The potentiometer is an instrument used for the measurement of potential difference. It consists of a 10-meter long uniform wire of manganese or constantan stretched in 10 segments, each of 1 meter length. What is the principle of a potentiometer? A battery Bt is connected between the ends A and B of a potentiometer wire through a key K. A steady current I flows through the potentiometer wire. This forms the primary circuit. A primary cell is connected in series with the positive terminal A of the potentiometer, a galvanometer, high resistance and jockey. This forms the secondary circuit. If the potential difference between A and J is equal to the EMF of the cell, no current flows through the galvanometer. It shows zero deflection. AJ is called the balancing length. If the balancing length is L, the potential difference across AJ is equal to IRL, where R is the resistance per unit length of the potentiometer wire and I the current in the primary circuit. Therefore, E is equal to IRL. Since I and R are constants, E is proportional to L.